equation we are told that the mileage of the car is a second degree function of speed. So mileage is of the form a into s square plus b into s plus c. We are also told that this mileage function attains its maximum value when the speed is 52 km per hour and it is equal to 28 km per liter. At what point does this particular quadratic equation attain its maximum value? For that, let us try to first complete a perfect square. So as square plus bs plus c can be expressed as a into s square plus b by as plus c by a. Or this term in the middle can be expressed as s square plus 2 times b by 2a into s plus b by 2a whole square plus a particular constant. This will be essentially equal to c by a minus b by 2a whole square. This is a perfect square and you have to multiply everything with a. Or essentially the given function as square plus bs plus c can be expressed as a into s plus b by 2a whole square plus some particular constant. The value of the constant is, as we have discussed, c by a minus b by 2a whole square into a, but we are not really particularly keen on whether the value is c or b by 2a or anything. We'll just call it a constant k. If you are expressing the quadratic equation in these terms, the maximum value occurs when the value of the speed is 52 km per hour and it is equal to 28 km per liter. Or essentially the mileage is of the form a into s minus 52 whole square plus 28. The reason for that is because when s is equal to 52, this term will become equal to 0. And whatever we are left is the value of k. So the mileage is of the form a into s minus 52 whole square plus 28. At this point, when s is equal to 52 km per hour, this becomes equal to 0 and the value will become equal to 28. We are also told that the mileage is 24.76 km per liter at 70 km per hour. So again, let us substitute the value of s to be equal to 70 km per hour. Mileage will become equal to 24.76. So 24.76 is equal to a into 18 square plus 28, or minus 3.24 is equal to 324 into a, or the value of a is equal to minus 1 by 100. So the function essentially becomes equal to mileage is s minus 52 whole square divided by 100 minus plus 28. Now you substitute the value of the speed to be equal to 42 km per hour. So you are going to get the mileage to be equal to 42 minus 52 is 10. So this is minus 100 divided by 100 in plus 28, which is equal to 28 minus 1 or 27 km per hour. The only thing we need to remember when solving this kind of a question is, if you are given the minimum value that a particular quadratic equation occurs at what point and the actual value, then we should express the given quadratic equation as a into x minus whatever is that minimum value whole square plus some number k. Now this quadratic equation is going to attain a maximum value when a is negative, and it will attain a minimum value when a is positive. Whenever you are told that a quadratic equation has a maximum value, by default then it is implied that a is negative. Whenever you are told that a quadratic equation has a minimum value, then it is implied that a is positive, or the coefficient of x square. And in this particular case, when a is negative, you want the square to be equal to 0. Only then will the value of m attain its maximum value, because otherwise this square will always be a positive number. You are multiplying it with a negative number, so the value is going to decrease. Plus k will be a number which is lesser than k. The maximum value of this m will occur when the first term actually equals 0, because the first term is either equal to 0 or it is a negative number. You don't want it to be a negative number when it attains its maximum value. So you can express the quadratic equation as a into x minus whatever is the minimum value at what point that is occurring whole square plus k. And at the point where it attains its maximum value, this becomes equal to 0, and the maximum value that is obtained is actually equal to the constant term, which is equal to k.